Are you tired of going through those never-ending videos and wishing you could just ask questions without watching the entire video? Well, in today's video, I'm going to unveil a superpower for you. I'll teach you how to make a question and answer chatbot for YouTube videos using tools like LlamaIndex, the awesome open source Llama2 model, Apache Cassandra, Gradient's LLMs, and Python. So stick around and let's dive into the world of interactive video watching. Before I jump and show you the actual implementation, I want to break this video down into the multiple technologies and tools that I'll be using to create the solution. So I'll kickstart the activity by starting the discussion on LlamaIndex. What exactly is LlamaIndex? Well, LlamaIndex, which was previously known as GPT-Index, is a data framework for large language model applications which provides tools to ingest, structure, and access private or domain-specific data. It's basically available in Python and supports a variety of data sources including unstructured data like documents, PDFs, videos and images, etc. LlamaIndex basically provides a high-level API that makes it easy to get started with data ingestion and querying, as well as lower-level APIs that allows advanced users to customize and extend any modules to fit their needs. So it basically gives you an entire framework where you can kind of have advanced retrieval and query interfaces over the data, which kind of allows you to feed in any LLM input prompt and get back retrieved context and knowledge augmented output. So this is the entire block diagram of how LlamaIndex functions. So you have documents like PDFs, Word files, and text files. All of that is converted into something called as an index. This index is stored into a vector database. Once a query arrives, there is a retriever that kind of retrieves relevant nodes based on the query. The query engine then decides which particular index to kind of display, and then you have the final response. So I'll kind of try to explain this even further. So think of a document like a PDF document that is loaded into LlamaIndex. The document are parsed or broken down into chunks, and these chunks are basically called as node objects. The node objects are split into overlapping chunks, and a semantic vector representation is computed for each chunk using a large language model. The semantic vector representations are then stored in a data structure called as a vector store. The vector store is used to build an index. So this is the entire indexing process that goes behind the scene when you kind of start using LlamaIndex. So once you have the query in place, there is something called as a retriever that comes in handy. So the retriever is a tool for extracting and gathering relevant information based on a user's query. So this plays a very vital role in terms of extracting the relevant answers for the query. So we've looked at most of the modules, but one piece that was still remaining is the query engine. So the query engine is built on the top of the index creator module and the retriever module. The query engine goes through the various results that have been kind of extracted by the retriever, and then it kind of selects based on similarity which is the most probable output and then gives out the response. So this is how the entire LlamaIndex functions. The next piece of discussion that I want to have is on the open source large language model that I'll be using for this entire activity, which is Llama2. So Llama2 has been open sourced by Meta, and it's basically an auto-regressive model. So it kind of released on 18th of July 2023 in partnership with Microsoft, and this is basically an open source model. That is something that I've already specified. Just to give you some context, Llama2 has been pre-trained on 2 trillion tokens, and we also had Llama1, but the context length of Llama2 is twice as large when you compare it to Llama1. There are 3 models which are there. So you have the smallest model with 7 billion parameters, then you have 13 billion parameter based model, and then you have a 20 billion parameter based model. So just to kind of highlight the improvements of Llama2 over Llama1, the first point is increased training on tokens. Llama2 is trained on 40% more tokens as compared to Llama1. Longer context length. So with a longer context, so Llama2 has a context length of 4K tokens. The current version of Llama2 has been fine-tuned and aimed at being optimized for dialogue applications using RLHF. So this is the uniqueness of Llama2. Given you can kind of run this entire piece locally as well, which is where I'm building the solution using LlamaIndex and Llama2. And I'll kind of show you the vector databases that I'm using. For vector databases, I'm using Apache Cassandra, which is what I'll discuss next. For using a vector database, I'm basically using DataStax's implementation of Apache Cassandra. I've already discussed the advantages of Apache Cassandra in my previous video. I'll add the link to my previous video so that you have a better understanding of why Apache Cassandra is so widely used. So you can kickstart the journey of using Apache Cassandra on DataStax by going to astra.datastax.com. Once you reach the website and once you sign up, you will have a prompt to create a database. So what you have to do is you have to select vector database, which is something that we'll require in this entire activity. Enter the database name, a key space name, select the cloud provider as Google Cloud. You can choose the other cloud providers as well. And then you can select the country. Once you go through the entire process, you will have an active vector database with you. All you have to do in order to use the database is you have to go to the connect section. So once you reach the connect section, there are two things that you require. The first thing is the application token. So if you look at the selection that I've made, you have to select database administrator and then click on generate token. So it will kind of generate a JSON file for you. The other piece that you require is a secure connect bundle. So for that, you just have to click on bundle and it will download a zip file. Once this is up and running, you've kind of done the heavy lifting with respect to the vector database. Now the other piece remaining is how do you access Llama2 model, which is where I'll show you the next solution. So there are many ways wherein you can access Llama2, but one solution that I really liked, and this is something that I've started using on a daily basis, is Gradient's LLMs. Gradient makes it very easy for you to personalize and build on top of the open source LLMs through a simple fine-tuning and inference web API. There are various open source models which are available like Bloom 560, Llama2, Code Llama, etc. Then there are various embedding models which are available, and Gradient also has integrations with LangChain and LlamaIndex, which is where I'm kind of using Gradient to kind of do the entire heavy lifting for us. In order for you to start using Gradient's LLMs, what you require is Gradient's access token and Gradient's workspace ID. And once you click on create workspace, it will kind of create a workspace ID for you. So you can find the access token in the profile section once you create your own profile and paste it into an environment variable, which I'll show in the coding section. So this is something that you require before you kind of start using the Gradient LLMs as well. Let's now start with the actual implementation. So for this particular activity, I'm using Google Colab, and I also have a GPU up and running. So I'm currently allocated a T4 GPU, which is something that I'll require in order to convert audio to text. So the transcription will require high-end memory power, which is where I'm kind of using a T4 based GPU. So this is something that I wanted to specify. Couple of more things that I want to specify is I have the token, which is my vector database token here. And I also have the secure connect zip file here. So this is something that I've already added to my current working session. So this is something that you will require in order to access the vector database, which is Apache Cassandra hosted on DataStax. The other piece, and I'm kind of happy that this exists right now in Google Colab, is you can have secret keys here. So what I have here is Gradient's access key and Gradient's workspace ID, which is something that I've created as a secret, and I'll kind of access it in the notebook itself. So this is something that I wanted to. Now let's start building our YouTube video based question and answer chatbot. So I'll quickly start the activity by the installations. So I'll require Cassandra, Gradient, LlamaIndex, and the other dependencies that are there. So I'll quickly select the cell and I'll quickly run this. This installation may take a while, so you will have to be patient in terms of the installation. So the installation took a while, but it's finally complete. So let's move forward. Let's now move forward and import the necessary modules that we require. So there are tons of modules that we require, as you clearly see. So I require the JSON module, the OS module, the Whisper module. So there are tons of modules. We'll quickly import them. And then we'll go line by line in terms of understanding how the entire kind of system or architecture kind of ties up. So let's quickly wait for the imports to happen. So the imports are complete. Based on the block diagram that you see on your screen, if I have to create a system that kind of answers questions with respect to the YouTube video, the first task that I have to perform is I have to extract audio from the YouTube video. This audio will be then converted to text using the Whispers module. The text will then reside in a vector database, which is where LlamaIndex comes in, and the vector database in our case is Apache Cassandra. Once the entire piece is set up, then I'll have my large language model hosted on Gradient, which will kind of help me ask questions in natural language. So coming back to the first point, my first task in hand is to extract the audio from a YouTube URL, which is what I'll achieve using this piece of code. So I have a function called as download_audio. I'm using the yt_dlp package. So what it does is, in the first line of code, I kind of pass in the arguments in terms of what I expect the audio format should be. Then I go forward and extract the useful information from the video details as well. So I'll quickly run this piece of code to import this particular function in memory. So this is one of my recent videos where I talk about Google speech to text. So this is something that I supply to a variable called as YouTube_video_URL. So I'll quickly import this particular cell in memory. And finally, I'll call the function download_audio and I'll pass the above created variable into this. So let me run this cell. So I have the audio file up and running with me. I'll quickly go here and check if the audio file is ready or not. So I have the audio file as well, which is an MP3 file. So if I rename the file, you can see that this is an MP3 file. So I'll require the file name going forward, which is what I'm copying in the clipboard currently. Now let's move on to the next section, which is extracting text from the audio file, which is what I'll achieve using this piece of code. The first thing that I'll do in this activity of extracting text from the MP3 file is I'll create a directory called as text_files. So let me quickly run the cell. Now if I go to the file section of Google Colab, there is an empty folder called as text_files, which I've just created. So all the text files that I generate can reside into this particular folder called as text_files. Now here is where I've created a function called as transcribe, which accepts a Whisper model and the location to the audio file. I call the model.transcribe function and I pass in the audio, and basically I open a file called as transcription.txt. Whatever text is generated from Whisper's model will all be outputted and saved into this particular file called as transcription.txt. So I'll quickly run this cell to import this particular function in memory. Now I'll download the base model of Whisper. So I'll quickly move forward and run this cell as well. So this is basically a 461 MB model. I didn't want a very large model. I didn't want a very small model as well. So you have options like tiny, etc. as well, but the small model kind of works really well, which is why I've chosen the small model. Now that the model is downloaded, I'll kind of make a call to this particular function, which is transcribe. I'll pass in the model and I'll pass in the file name. So both the input parameters are set. Now I'll quickly run this particular cell. So it's returned a 1. That means I have successfully extracted all the text from the audio file. So if I go to the file section again, and if I go inside the folder text_files, I clearly see a file called as transcription.txt. Okay. So the initial hurdle of extracting audio and extracting text from the video file or YouTube video is done. Now I'll move on to the next section, which is establishing a connection with my vector database. So this piece of code is something that I've directly borrowed from the DataStax website. It basically loads the secure bundle zip file. It also loads the token that you've generated. Once you provide the client ID and client secret, which are part of the JSON file, you kind of have the authentication done with the vector database on DataStax's cluster. And then finally you create a session. If you have a successful connection up and running, you will see a version. If there is an error, you will kind of see an error. So I'll quickly run this cell to establish a connection to my vector database. So finally, here is the release version. So there's absolutely nothing to worry about. We have like a good valid connection with our vector database. So our vector database connection is in place. The other connection that is missing is with respect to Gradient's large language model, which is where I have to configure Gradient's LLM API right now. So what I do is I import user data from google.collab. Just so that everyone's with me, I have the Gradient access ID and the workspace ID in form of a secret here in Google Colab. So I'll quickly close this. I create two environment variables, Gradient access token and Gradient workspace ID. So I quickly import that from the user data.get. So I'll quickly run this. So I have the environment variable set up. Now I'll define the Gradient's model adapters for Llama2. And trust me when I say this, it's not more than one line. This is how simply you can start using Llama2 using Gradient's API. Okay, so I'll quickly unhide the cell. And this is all that you require. So I've created a variable called as LLM, where I say I want to use Gradient's base mode LLM. I basically define which model am I using. So there is a concept called as slug, which Gradient uses. So I have to supply the slug in terms of which model I'm using. In our case, I'm using the Llama2 7B chat model, and I also define the max tokens. This is all that's required for you to use Llama2. So all the heavy lifting is done by Gradient's APIs. All you have to do is enjoy the power of Llama2 using Gradient's APIs. So I'll quickly run the cell. If you remember, there are some embeddings that have to be created while you kind of index the entire piece, which is where all you have to do now is define Gradient embeddings, supply the access token, the workspace ID, and the model slug again. So this is the model for the Gradient embeddings that I currently want to use. So I'll quickly run this cell as well. So my Gradient piece is also up and running. There's very little things that are required in terms of setting up the Gradient LLMs now. Now the other piece that is remaining, which is the main chunk of what we want to achieve and how do we want to achieve, is using LlamaIndex. So what I do next is I define the service context, which is from the default module of service context. I kind of define how I want to perform the indexing, what are the embeddings that I want to use. So which is where I define the large language model that I've created above, which is using Gradient's LLM. Here is where I define the embedding model, and I also define the chunk size. So this is the service context that I'm defining for LlamaIndex in order for it to create good indexes. And how does it create indexes is where LLMs come in and embeddings come in. So I'll quickly run this cell. We are almost near the final stage where you will see magic happen. So here is where the actual loading of documents and converting them into indexes happen. So I have a simple function called a simple directory reader, wherein I pass the folder name in terms of where the text file resides or where my PDF files may reside as well. So I'll quickly run this cell to load the documents that I have. So I'll quickly run this. So it says loaded one document. So I had one document, which is what it has loaded in memory. And finally, we reach at the indexing, querying and retrieval stage. So here is where indexing will happen, the embeddings will be generated, and all of that will be saved into the vector database. So here is where this particular variable comes in handy, which is index. For the index that I've defined, I've created an instance of the query engine, which is what I save here into the variable query_engine. So this query engine is basically a query engine for the index that I've generated. Now finally, I have the instance of the query engine up and running. Now I want to query my video with respect to some questions that I have in mind, which is where I have the response variable as response_out. I have the instance of query_engine to which I'll query and I'll ask some questions. So, and finally I'll kind of print out the response as well. So I'll run this cell and here is the response. The speech to text conversion in the given text file is done using Google's speech to text API. Did you see what just happened? And do you visualize what we are trying to achieve here? I have not seen the video, I have no clue what is the content inside the video, and I'm asking questions to the video and it's giving me the correct answers because I know what's there in the video, right? I've created the video. So this is truly mesmerizing in terms of what all you can achieve. I won't stop here, I'll ask some more questions. Does this require an API key? It says yes. In the video, the speaker mentions that in order to use Google Cloud speech-to-text APIs, you will require the credentials of the API. So it kind of gives the entire explanation in terms of why it is kind of giving out an answer. Let's see which programming language was used in this entire video. Let me ask a question. Which programming language was used in the solution? So it says Python. So I kind of create all my tutorials in Python, and it was smart enough to understand that I had created this entire video in Python because I would have mentioned Python here or there. I am truly mesmerized. I don't know what you guys, if you've stayed this far, I don't know what you guys feel, but I am truly mesmerized looking at the solution. I wanted to show you the power of vector databases, which in our case is Apache Cassandra. And the reason why I chose Apache Cassandra is because of the scale that it can take. I also wanted to show you the power of gradients LLMs in terms of how simple it is to create the large language model instance and start using it. So overall, this is all that I had in terms of today's video. I hope you enjoyed today's video and make it a point to subscribe to my channel for more such informative videos. Thank you so much for watching the video.